Hello and welcome to our lesson on simple distillation and fractional distillation. By the end of the lesson, you should be able to explain how simple distillation and fractional distillation work. Take a look at these two questions. What do these photos have in common? How can you separate liquids with different boiling points if they are mixed together? Now, if you look closely, all the products rely on the process of distillation to make them. As to this question, this is what the lesson is about. So hopefully by the end of the lesson, you should be able to answer these questions. That means you know how to separate liquids if they are mixed together and they have different boiling points. Sometimes it can be close, other times it can be huge difference in their boiling points. Now, how does simple distillation work? This is easy to carry out in the lab if you have the right equipment. You can use evaporation to separate and collect the solute. So in evaporation, you want the solute, the solid, salt or sugar mixed with water. But in distillation, you want the liquid, the solvent, not the solid. Now, this can happen in three steps. You need to evaporate, use evaporation, condense the liquid, and obviously collect the liquid. So this method is used to separate a solvent from a solution. So a liquid from a liquid. The solvent has to have a much lower boiling point than the solute. When the mixture is heated, the solvent boils, but the solute does not. So let's use this example, inky water. That's ink mixed with water. Now, ink has a higher boiling point. Water has a lower boiling point. So the boiling point of water is lower than the boiling point of ink. So when you heat, the water turns into a gas first. It goes up here, goes through the condenser, and is condensed and collected as liquid. The ink remains in the round bottom flask. You need to run cold water in to speed up the process of condensation, which is turning water vapor into liquid water. Now, fractional distillation, how does it work? With simple distillation, there's a big difference in the boiling point of the liquids. Now, with fractional distillation, the difference is not huge. So ethanol boils at 78.4 degrees Celsius and water boils at 100 degrees Celsius. So they will almost boil at the same time because the boiling point is so close. This is where we need fractional distillation. And with fractional distillation, you have a fractionating column where the magic happens. Now, this is water and ethanol in this case. As water has a higher boiling point than ethanol, it condenses on the inside of the column. So this is the fractionating column. When both mixtures boil, ethanol and water, they will rise up the fractionating column because they're turning into a gas. But because of the distance, as the gaseous water in gas state is moving away from the heat source, it starts to condense because the temperature here is not as high as the temperature here. It starts to condense and fall back as water, whereas the ethanol carries on in its gas state or gas form, goes through the condenser, it is condensed back into liquid ethanol and is collected here. So this apparatus has a fractionating column, as you can see. You need it to separate liquids with similar boiling points. So wide gap between the boiling points of the liquids you want to separate, you can use simple distillation. If you want to separate mixtures with very similar or close boiling points, what you want is fractional distillation. Thank you very much.